Dear friends, in the last class we discussed about the functional decomposition of systems, and we discussed about one method called Hartley-Pirbat template or HP template, and how to use this HP template for decomposition of functions and then getting a functional architecture based on the hierarchy of the functions. As mentioned, there is one more method I would like to discuss today, and this method is known as IDEF0. Basically we use a template called IDEF0, and using this template we decompose the functions and get the sub functions, and then using these sub functions we create a hierarchical function structure. IDEF0 is basically a graphical method where we identify the functions and their interrelationships and all the control signals, everything we represent it using a graphical method and create graphical sketches of these functions in order to identify the sub functions. Basically this method known as integrated definition for function modeling, or in short IDEF0, 0 was added, is a first initial chart, that is why it is known as IDEF0. This is integrated definition for function modeling. This was developed by US Air Force in order to develop some of the aircraft systems or defense systems and to identify the functions needed. So this actually answers definitive questions about the transformation of inputs to outputs. Basically any function can be considered as a relationship between input and output, and therefore this method answers the question about the transformation of inputs to outputs. So what actually happens to the inputs, and what are the transformations the input is going through in order to get the outputs, and this can actually be clearly answered using the IDEF0 chart. And it is a coordinated set of diagrams using both a graphical language and natural language. So this is basically a graphical representation. So we use some of the graphical language as well as the natural language to describe the functions. Here we use different diagrams, and A-0 or A0 page is the context diagram. So basically this diagram gives the overall function of the product or the system and gives the inputs, outputs and the control signals as well as the mechanism through which the system operates. So A-0 is the context diagram, and then we use different diagrams like A0, A1, A2, which are the level 0, 1, 2 diagrams. So and this actually goes on till we reach the final or the last sub function, which we do not need to decompose further. So the number of levels are not fixed, but actually depends on the system and its functions. So as I mentioned, there are different levels of diagrams. So we can actually show it as the A0 page, that is the context or system function diagram. It defines the inputs, controls, outputs and mechanisms, or known as ICOMs. So in this diagram we represent all the inputs, the controls, outputs and mechanisms for the single top level function, and this top level function is labeled as A0. So A0 is a function in the context diagram A-0, and here we represent all the inputs, controls, outputs and mechanisms. Then we have the A0 page, which is the A0 function decomposed into its level 1 functions. So the level 0 diagram, A0 is the level 0 diagram with first tier functions specified. So in A0 diagram we specify the first tier functions, and they will be referred as A1, A2, A3 and so on as the number of functions. So A-0 or the context diagram contains the function A0, and A0 diagram or the level 0 diagram contains the functions level 1 functions A1, A2, A3 etc. and so on it goes. The A1 diagram, A1, A2 etc. are the level 1 diagrams with the second tier function specified, and A11, A12, A21, A22 etc. are the level 2 diagrams with third tier functions and so on, and it goes on till we reach the final decomposition stage. So here as mentioned there are A0 context diagram, and then A0, A1, A2, A11, A12 and A21, A22 diagrams, level 1, level 0, level 1 and level 2 diagrams. So this is actually shown over here. So this is the diagram, this is known as A0. So this is the A0 diagram here, and then you have the inputs, outputs and control diagrams. So here you can see the inputs I1, I2 are the inputs to this top level function or the A0 function, and then C1, C2, C3 are the control inputs, and then O1, O2, O3 are the outputs, and then you have here the mechanism through which this transformation takes place. So that is the top level context diagram A-0, that is a context diagram, and the same diagram can be expanded to the next level, which is known as the A0 diagram, where you will show the A1 functioning, A2 functioning and A3 functioning. So this is shown separately in more detailed explanation. So you can see here, this is the first level A0 diagram with I1, I2 as the inputs, C1, C2, C3 as the control inputs, O1, O2, O3 as the outputs and control inputs, sorry, this is control input, and this is the output, and this is the mechanism through which it is converting the I1, I2 into O1, O2, O3 as determined by C1, C2 and C3. So that is the top level function A0, and then this A0 function is divided into its sub functions in the A0 diagram or the level 1 diagram. So here we show the input I1 and C1, which is acting on the function A1, which actually transforms input 1 to output 1 and output 2.1 as determined by C1 and C2. So using M1.1, so this is the M1.1 mechanism, and then here you can see the transform, this is another function, this is A1 function, this is A2 function, and this is A3 function. So the main A0 function is divided into or decomposed into 3 functions, A1, A2 and A3, and all the inputs and the controls are shown separately for this one. So here you can see I1 is an input to A1, I2 is an input to A3, but I1 is going again to A2 also. Similarly, C1 is a control input to A1, C2 is a control input to A2, and C3 is a control input to A3, and the outputs are O1 is coming from A1, O2 is coming from A2 and O3 is coming from A3. So this is just a typical representation. It is not necessary that O1 should come from A1 or O2 should come from A2. It actually depends on the function. Depending on the function, the output may come from one function or the output may come from different functions. But the beauty of this representation is that we can actually show all the inputs and the controls as well as the outputs separately and their interaction between the sub functions. As you can see here, the output from A1, which is the output O1, this is actually going to A2 as a control input to this, and then this is going to this as another input also. O2.1 is going to as an input. So similarly, the output is O2.2, which is going from here, and that is again going back to, that is coming from A1 also. So like this, you can have different interaction between these controls and outputs within the function. So this can be represented using the IDEF0 diagram. So take an example to show the functional decomposition using IDEF0 diagram. So here we take the example of elevator, which we discussed earlier also. So now you are familiar with the elevator system and its requirements. So we will actually take this same case study and then use that one for explaining the functional decomposition using IDEF0 diagram. As you can see, this is the context diagram. You can, this A0 is the top level function which is provide elevator services, and all others are inputs and control signals and outputs, and you have the mechanism as the elevator system, as the mechanical system which actually provides this service. So there are different inputs. You can show it in a better way in this diagram. So you can see here, this is the context diagram. So these are the inputs, the passenger characteristics are inputs, electric power and emergency communication response is the input, the service test and repairs are the inputs here, and here you have other inputs like request for emergency support and emergency message, request for floor and exit support, request for elevator service and entry support. Similarly, the structural support, alarm signals and building environment, and modified elevator configuration expected usage patterns. This is basically based on the patterns that also will be given as an input to the system. So these are all the inputs going to the system, and the output coming from the system are the passenger environment, what is the status of passengers in this particular scenario, then the acknowledgement that request was received and status information, basically as an output the present status of the request provided by the customer. So, what is the status and an acknowledgement, and diagnostic and status messages, whether any problems are there or any troubleshooting is to be done or any servicing to be done, that kind of diagnostic messages will be given as output, and emergency communication from the elevator to the external system to the police or fire service or to the building administrator. So, that will be given as emergency communication, and elevator entry exit opportunity provided by the system, and then emergency support under in emergency situations, like supporting the passengers in the case of an emergency by providing opening the doors or going to the next level of wherever the access is available. So, these are the outputs coming from the system. So, as you can see here, the elevator system is the main mechanical system which actually provides elevator services. So, here the elevator system is converting all these inputs to outputs and giving it as outputs. You may have noticed the red line over here and a dotted line. So, this is basically to for another purpose. This diagram can be used for tracing an input and finding out what actually happens to this input or what kind of conversion taking place these inputs. We will see that later once we complete the discussion about the IDF0 diagram. In one of the applications of an IDF0 diagram, I will explain this at a later stage. So, this is the context diagram which provides the overall main function of the elevator system as well as the inputs and outputs. So, the next task is basically to divide this function into sub functions. So, the context diagram will provide you the top level function A0, and the A0 diagram or the level 1 diagram will provide you the sub functions A1, A2, A3, and see how to show that using IDF0 diagram. So, this looks a bit difficult to read, but I will show you another diagram where the details are given. So, overall picture is shown here. So, you can see that this is the accept passenger request as and provide feedback as one function, control elevator cars as another function, move passengers between floors as another function, and enable effective maintenance and servicing as another function. So, in A0 diagram, that is the level 1 diagram, we decompose the top level function or A0 function into A1, A2, A3 and A4. Similarly, we identify the inputs and outputs, inputs to the A1 function and the output going from the A1 function, and whether these outputs are being used by the A2 function or they are going directly to outside the system. So, all those can be represented using this diagram. So, here we write down the signals, the input signals as well as the output signals, and represent if there is any input output coming from the system represented separately with the text descriptions. So, to go into the details, as you can see here, this is basically the decomposition A1, A2, A3, A4. Basically, we are taking the A0 function and dividing them to A1, A2, A3 and A4 as shown here. So, this is A1, A2, A3 and A4. As you can see here, so this is the first one, A1 function, accept passenger request and provide feedback. That is the first function of decomposition A0, and the inputs are request for emergency support and emergency message, request for floor and exit support, and request for elevator service and entry support, and these are the main inputs coming from the passengers. And other inputs are electric power and emergency communication response that will be coming to this function. So, these are the inputs coming to this, and from here we will be getting outputs, many outputs from here, and some of the outputs will be going to function A2. As you can see here, one of the output from this function is digitized passenger request. So, here the passenger request is digitized and sent to the next function called control elevator cars. So, this is the function A2, and from here you can see there are other inputs also coming like modified elevator configuration expected usage pattern. We discussed about this input in the context diagram. So, that input is coming to control elevator cars, and other inputs are coming from other sources. From the other functions also inputs will be coming to this function, and it will process all these inputs and give the output like configuration controls and assignments of elevator cars. That is one of the important output from this function, assignments for elevator cars. So, which car should go to the which floor and where it is, all this information will be processed and the assignment will be sent to this one. and that will go to the third function called move passengers between floors. So that is the A3 function. So here the one input is basically the elevator car assignment, the other one is the building and environment, depending on the structural support, alarm signals and other inputs will be provided, and that input also will be processed along with the configuration control inputs will be processed here, plus you will be getting other input from here like electric power, emergency communication and passenger characteristics. So all these will be processed, and this function called move passengers between floors, and then you will be having the passenger environment as the output and elevator entry exit opportunity as output from the A3 level function. So this is A3 level function, and then the last function is basically to enable effective maintenance of and servicing of the system. So in order to provide the elevator services, we need to have the effective maintenance servicing also. So the input from various sources will be coming about the status of all the functions and other controls will be coming here, and the sensed malfunctions also will be coming as input, and based on this function will process the diagnostic and status messages, and that will be sent to as an output from here, and these queries also will be used by other functions in order to execute their functions. So like this you can see the main function A0 is divided into A1 function, A2 function, A3 and A4 function, 4 sub functions, and the inputs and controls to these functions are shown clearly in the A0 diagram or the level 1 diagram. So this first level function is basically to get the decomposition of the main function into the top level or the top tier level 1 functions, and then now this level 1 function, each function in the level 1 need to be decomposed further to its sub components or the sub functions, and this is done in the level 2 diagram or A1 diagram. In A1 diagram we use or A1 or A2 A3 diagram, basically A1 diagram will show the decomposition of A1 function, A2 diagram will show the decomposition of A2 function, and A3 will show the decomposition of A3 functions. This is shown here. So this is the A11 function, so 1 is missing here. So this is basically A11 function, this is A12 function, and this is A13 function. So in order to provide service to the waiting passengers, so there are 3 functions need to be there, that one is that support waiting passengers, support riding passengers and support passengers in emergency. So this is the provide service to the passengers, that is the A1 function is divided into 3 sub functions like support waiting passengers, support riding passengers and support emergency passengers in emergency. Again we will see how this, you can see this is the diagram A1 diagram, that is accept passenger request and provide feedback, which is the main function, and that is divided into 3 functions over here. We will see the details of the input and output for this. So as you can see here, this is the A11 function. So A11 function is the support waiting passengers. So you can see here the inputs are request for elevator service and entry support, and elevator position and direction, these are the inputs, and of course the diagnostic queries coming from the maintenance function is also coming here. So based on this will provide the information to waiting passengers. Basically the waiting passengers need to know where the elevator is and where it is moving, what is the status of the elevator, whether it is in working condition or it is in the service mode or it is under a breakdown or it is going to serve the passengers. So that information need to be processed here and given as an output to the passengers. So you can see here the output will be, this is the output, acknowledgement that request was received and status information. This will be given as an output from this particular function. So acknowledgement and status for waiting passengers as the output from the function A11, which is support waiting passengers. So similarly we need to have support for the riding passengers also. So in case of there is any malfunction, you can take that is also an output from here. The sensed malfunction will be going to the service and maintenance function, or it is going as an output from here and it will go to sensed malfunction as a output from this particular block, that is from the A1 block, and it will go to the A4 function which we discussed in the previous slide. So the next one is support riding passengers. So riding passengers, the information are basically the inputs are the elevator service and entry support inputs and floor and exit support and digitized requests from waiting passengers. So that is the waiting as well as waiting passengers also will be going as an input to the elevator. Apart from supporting the riding passengers, it has to take care of the input request coming from the waiting passengers also. So support riding passengers, this also is a input. And other inputs are like elevator position and direction and diagnostic queries are the inputs. So it will process these inputs and then provide the output like digitized request from riding passengers. So the riding passengers will be giving some commands or the giving the input, and based on that it will process the request and give the digitize the request and give to the control as output to the control elevator car function. And similarly acknowledges and status for riding passengers. So riding passengers also will get some acknowledgement and present status of the elevator or whether the request has been accepted or it has been received. So that information also will be provided by this particular function. And the third one is support passengers in emergency. So you can see this is first was support waiting passengers, the next one is support riding passengers, and the third one is support passengers in emergency. And here also the input, basically the input will be from the passengers, riding passengers or the waiting passengers, both will be giving input, and emergency support and emergency message will be the input here where to send the message, and that input will be there, and of course malfunctioning messages also will be coming here. Based on this function will generate necessary control signals, emergency communication signals and emergency support, and the information will be passed to other functions also. So like this, these are the input outputs coming from these functions. As you can see, there is a lot of interaction between these functions within the system. So the input from one function will be output from one function will be an input to another function, and similarly the output will be, can be one function can be input to a previous function also. So you can divide the main A1 function into A11, A12 and A13 in this diagram. So this diagram is basically basically the A1 diagram where the A1, A2, A11, A12 and A13 functions are decomposed and their interactions are clearly shown. So that is the A1 diagram. Similarly we can have A2 diagram also. So in this A2 diagram we divide the A2 function, that is from the A1 or the level 1 diagram, we take the A2 function which is the control elevator cars and divide this into sub functions A21, A22, A23 and A24. As you can see here, this is the A21 function which is monitor location of all cars. Basically in order to control the elevator cars we need to monitor the location of all cars, we need to monitor the location and direction of all priority waiting passengers, and we need to monitor the location and direction of all non-priority waiting passengers and all allocate cars to passenger pickup stops. So these are the sub functions to be provided in this function, that is control elevator cars need to have these functions in order to satisfy the requirement of control elevator cars. So the first function is monitor location of all cars. Let us see the input and output of this function. As you can see here, this is the monitor location of all cars. So the diagnostic queries will be there and the inputs will be coming from the passenger, output from the location, that is this is the one of the input, that is allocate cars to passenger. So that information will be there and that information will also be going to this one to monitor the location of the cars. So based on this information it will continuously monitor the location of all cars and give this as an output to the other function of allocating the functions. So and any sensed malfunction also will be given as an output. So there will be an output which actually gives the position of the elevator cars and malfunctioning of these cars if any. And the other one is monitor location and direction of all priority waiting passengers. So priority waiting passengers will be having a separate input processing, so that data will be coming here, digitized passenger request will be coming over here and the location of cars also will be coming here, and based on this it will actually locate where the cars are and that information will be sent to the next level function to process the input for the allocating the cars. So this output from here, the monitor location and direction of all priority waiting passengers, the output will be sent to the allocate cars to passenger pickup and stops. So list of all floors with waiting priority passengers and desired direction will be sent from here to this function, that is to allocation of cars. Similarly, the location and direction of all non-priority waiting passengers also will be monitored, again using the input from the passengers, and these inputs will be used to find out where the passengers or the non-priority passengers are there, what are their requests, and that information also will be sent to the allocate cars to passenger pickup stops. So this is the main function which actually will allocate the cars, but basically it requires the information from these other functions in order to process the information about priority passengers and other passengers, and based on these inputs it will allocate the cars to different floors and for different services, that is assignment of elevator cars. So we can see here the control elevator cars as a function. In order to satisfy the requirements, it has to provide the sub functions like monitor location of all cars, then monitor location and direction of all priority passengers, as well as the location of non-priority passengers, and this information will be used by the function to allocate cars to different floors. So that is the decomposition of A2 function into A21, A22, A23 and A24. Similarly, you can divide this A3 function, which is move passengers between floors, that is the function A3. Again in level 0 diagram we identified these functions A1, A2, A3 and A4. So based on this we can actually decompose this A3 function into its sub functions. So move passenger between floors, one sub function is receive and discharge passengers. So that is one function, we need to receive and discharge passengers. We need to travel to next stop, so the elevator has to travel to the next stop and provide comfortable atmosphere within the elevator. So these three functions need to be satisfied in order to satisfy the function move passengers between floors. Here again you can see receive and discharge passengers, you can see the inputs are configuration controls and other information coming from the travel stop messages coming from the elevator cars, and then the electric power and other inputs are also here. Similarly, it will get the input from other location like elevator car door status, cars component are the mechanisms which actually use this mechanism to provide the receive and discharge passengers. So these are the mechanisms through which this function will be executed, that is elevator car doors, elevator car component as the mechanism, and it will provide the opening and closing of the doors to receive and discharge passengers. And the output will be the sense discharge malfunction. In case there is any problem with the doors, then that will be sensed here and will be sent to the maintenance function, and the message will be sent to the next one, that is travel to next stop, that is if the function to receive and discharge passengers has been accepted or it is functioning properly, then that message will be sent to the next function. Basically it will go to the next floor if the passengers have been accepted or they have gone into the car and safely, or they have been gone out of the car safely, then that message will be sent to the elevator. Then based on that information, elevator will move to the next floor to accept passengers or to discharge passengers. That is the next level function, travel to next stop. Then provide comfortable atmosphere for the passengers. So that also is a function, we need to provide a good atmosphere within the car. So that again is a function. So there will be many systems inside to provide the comfort to the passenger like a fan or air conditioning or other emergency services. So all those services will be monitored, and in case of any malfunction that will be sent, that information will be processed and sent to the maintenance function, so that passengers will be always getting a good comfortable atmosphere within the car. So in order to move passengers between floors, we need to provide these functions within the elevator, otherwise we will not be able to provide the necessary satisfaction to the customer. So the sub functions are receive and discharge passengers, travel to next stop and provide comfortable atmosphere, all these are, and then the passenger environment and sensed malfunction, elevator position and direction, and discharge malfunction, and these are all the output coming from this function A3. And A3 outputs we actually saw in the previous diagram or the level 1 diagram, you can see the same outputs will be coming here also, but they will be coming from different functions, it is not from the same function, there will be many sub functions and some of these sub functions will be providing this output. So we need to find out which function is providing the output and accordingly we need to design the system so that it will take the input and provide the output to the next system or the next subsystem. So that is the A3 diagram where it show the decomposition of A32, A31, A32, A31, A32 and A33. So this is the the detailed diagram here. So receive and discharge passengers and travel to next stop A32 function, and then you have this provide comfortable atmosphere to the passengers. So these are the sub functions and the outputs are here: passenger environment, sensed malfunction, elevator position, and these are the outputs, and these are the inputs: electric power, emergency communication, passenger characteristics, and the control inputs are configuration controls and assignment of elevator cars. These are the control inputs coming to this A3 function, and these are the outputs coming from A3 function, and this A3 function is providing these outputs through sub functions A31, A32 and A33. So that is the way how we actually divide these functions using IDEF0 diagram. As you can see that in the top context level diagram we have the A0 function alone, and in the level 1 function, level 1 or the A0 diagram, we divide this A0 function into sub functions A1, A2, A3 etc. And then in the next level we divide this A1 function into its sub functions A11, A12, A13 or A2 to A21, A22, A23, and again if you go to the next level, this A21 function will be further divided into A211, A212, A213 etc. So like this we will be keep on dividing these functions till we reach the stage where we know that we do not really need to decompose these functions, because some of these functions will reach to the lowest level of function where we can really identify a component which can actually provide that function. So till then we will keep on decomposing this function into the sub function and provide the and get the other sub functions, and we will be getting many diagrams like A0 diagram, A1 diagram, A2 diagram, or level 1, level 0, level 1, level 2 diagrams, and all these diagrams can be combined together to find out all the functions, and then based on this we can create a functional hierarchy of the system, or the function the functions can be used to get the functional structure of the system. Basically we are decomposing the main function into the sub functions of the system. But one advantage of using IDEF0 diagram is to look at the scenario tracing, or to evaluate the functional hierarchy, whether we are providing all the functions or we are missing some of the functions in the system. So that can be done using the functional hierarchy or scenario tracing. Basically the scenario tracing will identify two things. One is the shortfall of functions. A shortfall is basically the absence of a functionality that is required to produce a desired output. So we know that there is an input and there is an output, and when we go through the scenario we see that there is one function missing which actually converts an input to output. So that absence of the functionality can be identified, and this is known as the shortfall of functions, or an inability to produce a desired output, or functions identified cannot produce an output which actually you want, or insufficient control signals to produce the output, or the control signals provided is not sufficient to produce the output. So these are known as the shortfall in functional hierarchy. So we use these diagrams to find out whether there is any shortfall in the functions we identified. So it can be an absence, or it can be an inability to produce an output, or it can be an absence of a control input to produce the output. And there is another one called overlap, which is a redundancy in functionality that is needed to achieve additional performance. So sometimes we provide additional functions which may be redundant and which may not be required at that point or that location. So that also can be identified using scenario tracing. So the functional overlaps, unlike physical overlaps, are not needed. So we do not really need to have functional overlaps. Of course we will provide physical overlaps in order to provide redundancy in the hardware, but in the function overlap is not needed. If you can identify a function, one function is sufficient to produce an input, an output from an input. We do not need to have an alternate or another function to do that. So that actually can be avoided in overlap. So if you go through the scenario tracing, we can identify the shortfall as well as the overlap of functions and check whether the functional hierarchy is proper or whether any modifications are needed in the functional hierarchy. Let us see how we do this using IDEF0 diagram. So as I mentioned earlier, from the context diagram we can actually take any one of these inputs and see what is the output coming from there, and we can find out what is happening to this input as the input goes through different functions. So this is known as the scenario tracing. So in this case we take the request for elevator service and entry support as an input and see the output as elevator entry exit opportunity. So customer is giving a different diagram. So we can see here the request for elevator service and entry support as an input. So we want to find out, want to trace the scenario what actually happens once a customer gives a request for elevator service. So the customer is giving for a service for the elevator service, and based on this request the elevator will function and provide an output of entry exit opportunity. So that is the final output coming from the elevator for this input. But what is happening to this input within the functions or within the sub functions, and how this input is converted to an output of like this. So we trace this scenario and try to find out all the function which actually comes in between and how this input is converted to an output. That is known as the scenario tracing, and we use that one to find out the absence of any functions or overlap of the functions. Okay, so this is the A0 diagram. So we started from the context diagram. In the context diagram the input is given to the system and an output is coming from the system. And now we look at the A0 diagram where the sub functions are there and we try to trace the inputs. So here we take the input from here, so you can see this is the input, request for floor and exit support. So that is actually coming to function A1, and from A1 it is going as digitized passenger request. So this request is processed here in A1 and it is going as digitized passenger request, and that request is going to A2 function, that is control elevator car, and then control elevator car is giving the assignment of elevator cars, and that is the output from here for the same input of request, that is converted to digitized request, and that is coming to control elevator cars as a control input, and then control assignment of elevator car is coming as an output from this function, assignment of control of elevator cars, and then it is going to the next function which is move passengers between floors, and here you are getting an output, that is the elevator entry exit opportunity. So we are actually tracing that input which is the request for entry exit or the elevator service, and that request is being processed in these functions and coming out as an output of elevator entry exit opportunity. So we can see that this A1, A2 and A3 functions are using this input and processing this input to various forms and then getting the final output. As you can see here, the A4 function is not using that input, and therefore we do not need to look at the A4 function for further tracing of this signal. So now if you want to find out what is happening to this signal in this function A1, we have to go to the next level or the A1 diagram or level 2 diagram and then find out what is happening to this input. So request for floor and exit support. Similarly, what is happening to the digitized passenger request and how is it converted to elevator cars, we need to go into this function and then find out the path through which the signal is passing. So we will go through this and different these stages. I mean, we go to the A1 function and its sub functions, similarly A2 and its sub functions, and A3 and its sub functions to find out the scenario, to trace the scenario of the passenger request. So here you can see this request is converted to a digitized passenger request. We know that there can be a function which actually converts this input, and that is what we need to find out whether there is any shortfall or any overlap of functions in this one conversion of passenger request to digitized passenger request. So what we are doing is going to the A1 diagram. that is A11 function, A12 function, A13 function, and seeing what actually happens to this request. Again we will see. So this is the request for elevator service. So that is the coming here, support waiting passengers, and in support waiting passengers the data is coming here and going out as acknowledgement or status for riding passengers, and then the digitized passenger request from waiting passengers and request from entry support is coming over here. So actually you can see that this function is coming here and going out from here. Similarly you can actually say the acknowledgement and status for riding passengers is coming from this function. So both the functions, support waiting passengers function and the support riding passengers function, both are using the request for entry airport support signal and converting that into digitized output. So again if you further down into A11 you can see that there will be a component or an electronic component which actually converts the signal to digital signal and sending it to the next function. So A11 as well as A12 are providing the digitized using this signal and then giving the information out to the next level function. So in order to find out the function we need to go further deep into this support waiting passengers and then go into it and then see what is happening to this signal, or which is the function which actually transfers this signal to digital signals. So this is the way how we actually trace the scenario. We go through each input and find out all the functions through which it passes and try to find out whether that function is really capable of transferring the input to output, or is there any overlap of function which actually is redundant in transferring the input to output. So that can be done through this diagram. So we go through each and every functions through which the signal passes and finally identify all the functions which correspond to that signal and then look for any shortfall or overlap. So that is the way how we actually process the signal here, or process the use the IDF0 diagram to trace the scenario. So this is basically about the IDF0 diagram and how this can be used for functional decomposition. So what we discussed here was to look at the IDF0 diagram as such. Basically it is a integrated definition for system functional decomposition. So which was developed basically for aircraft design or air system design, and we know that there are context diagrams. This context diagram is basically giving the top level function and then identifies all the inputs, outputs, controls and the mechanism, and then from the context diagram the function can be decomposed into sub functions A1, A2, A3, which actually in the A0 diagram we represent it, and then A1 function can be further decomposed in A1 diagram where the A11, A12 etc. So like this we can keep on decompose these functions and finally get all the sub functions. That is the advantage of using IDF0 diagram. It is a graphical representation where we use the text also to represent the inputs and outputs. Apart from representation we can use this for tracing the scenario to find out the shortfall or overlap of functions also. We can see few more examples in the next class. So in the next lecture I will take one simple example and then show you how to use this diagram in order to decompose a system top level function into sub functions. So till then bye.